Welcome back.
All right, so we're going to talk about inverse equations today. The warm-up here says the inverse of a graph is obtained by switching the x and y coordinate. So basically, to graph an inverse, if you know what the original function looks like, then you can graph the inverse by just simply by switching x and y. So the inverse equation is obtained by switching the x and the y in the equation and then solving for y. So it says write the inverse for g of x equals 3x minus 6. Now, in part A, it says to actually graph it. So let's take a look at graphing y equals 3x minus 6. So here we go. All right, so I've got 6. I guess I need a pen color here. So we'll choose red. So I've got 6, negative 6 as my y-intercept, a slope of 3. So up 1, 2, 3 over 1, up 1, 2, 3 over 1. And so I can graph this line simply by doing that. All right, the inverse, so this is g of x. All right, the inverse is simply obtained by switching the x and y in each coordinate. So what I'm going to do is I'm going to list each of the coordinates here, and actually let me go back to red here. I'm going to list each of the coordinates on g of x. So my first one was 0, negative 6. And my second one was 1, negative 3. 1, negative 3. And my third one was 2, 0. So the inverse equation is obtained simply by switching those around, the x's and the y's. So my inverse is going to be negative 6, comma 0, negative 3, comma 1, and 0, comma 2. So we're going to graph those 3 points. 0, comma 2 is up here, negative 3, 1 is here, and negative 6, 0 is here. So there's my inverse. All right, and while we're at it, I'm going to introduce some new notation here. So the inverse equation is still a g function, but we use g of x. Okay, so you notice I left a little space here, and then we use this notation. We give it what looks like an exponent of negative 1, but it's not an exponent. It just simply means the inverse of g. All right, so as you can see, I mean, if you look at the inverse of g, it's still a line. You'll notice that the slope of g is positive 3, 3 over 1. Look at the slope of the inverse. It's 1/3. So I have a slope here, m equals 1/3, where my slope of g was positive 3. M equals positive 3. So the slopes are simply reciprocals of each other, not opposite reciprocals like you saw in perpendicular lines, but simply reciprocals. So we're going to write the inverse equation for g of x. All right, so I'm going to go back to blue here. And so the inverse is obtained by switching the x and the y. So I'm going to write x equals 3y minus 6. And I'm going to solve for y. So we're going to add 6 to both sides. We'll do plus 6. So we have x plus 6 equals 3y. I'll divide out the 3 on both sides. Now, you may divide differently, but when I divide, I typically divide each term. Depends on what I need to do with it. But basically what I have now is 1/3. Okay, so that's x over 3 is just really 1/3 x plus 2 equals y. And now I'm going to change the y to what we call a g inverse. So I'm going to rewrite this as, oops, lowercase g. Let me get rid of that and try this again here. So g inverse, so that little negative 1 at the top, g inverse of x equals 1/3 x plus 2, which means my new function should have a y-intercept at 2. So this is my y-intercept, and it should have a slope of 1/3. Well, we already know that the slope is 1/3 because we checked that earlier, but look at where the y-intercept is at, 0, 2. All right? So part C says, is the original graph a function? Well, yes, it is a function. Yes, because it passes the vertical line test. VLT, vertical line test. Is the inverse graph a function? Well, run your vertical line over that, and you also get yes, because it passes the vertical line test also, VLT. All right, so both of those are functions. That is not always the case, as we're going to see now in example number 1. All right, so here we go. Number 1 says graph the equation and its inverse. So if I can get another color here, here we go. Let's try some green on this one. So I want to graph this equation. I know that this equation has a vertex at -3, -4. So I'm going to start there, -3, -1, 2, 3, 4. So right here. It has a slope of 2 up the right side, up 2 over 1. A -2 up the left side. I keep going. And so I have this graph right here. It's absolute value. It should be a perfect V, and it is. All right? So part A says, is the graph a function? And why? The answer is yes. Passes vertical line test. All right? So now we're going to graph the inverse. In order to graph the inverse, I need some points from the original graph. Okay? So I've already got the vertex listed up here at -3, -4. So I'm going to list some of these other ones. So I had a -5, 0. I also had a -4, -2. I also had a -2, -2. And I also had a -1, 0. So these points, all 5 of them, are on my function. All right? Now, I want to graph, is the inverse graph a function? Well, I don't even know because I haven't graphed it yet. So I need some inverse coordinates here. So I'm going to start with those. All right? So if you check it out, I'm going to start with the vertex again. Because guess what? The vertex of the original is the vertex of the inverse. Isn't that nice? So I'm going to do -4, -3. Then I'm going to switch all 4 of the others. So I'm going to do a 0, 5. I'm going to do a -2, -4. I'm going to do a -2, -2. And I'm going to do a 0, 1. All right, so let's graph these guys. -4, -3 is right here. 0, 5. 0, 5. Wow, 0, 5. Way up here? Did I do that? Oh, so you know what? This should be 0, -5. Sorry about that. 0, -5. So 0, -5. 0, -5. Oh, that's down here. Okay, I was looking at the wrong spot. Okay, so 0, -5. -2, -4 is right here. And -2, -2. Oh, look at that. I'm going to overlap the old graph. And 0. This should be, you know what, I blew it on this one too. This should be -1. Hopefully you caught that while I was doing that. And maybe you were paying attention even though I wasn't. All right, so check it out. I still have a V graph, but this V graph doesn't go up or down. It goes to the right side. So is this a function? The answer would be no, does not pass. Does not pass vertical line test. So in the first example, the graph and its inverse were functions. In the second example, the original graph is a function, f of x, but the inverse is not a function. Okay? So just keep in mind that not all inverses, if the original is a function, that doesn't mean the inverse is going to be a function. The next question says, how could you know if the inverse of f of x is a function just by graphing f of x? Well, there's a couple of things you have to think about here. So if we know that if my green graph, if f of x passes the vertical line test, then it's a function. Okay? And if my inverse passes the vertical line test, it would be a function also. Okay? But the question is specifically asking, how could you know if the inverse of f of x is a function just by graphing f of x? Well, here's the thing. You'll notice that when I graphed the inverse, the gray one, it turned to the right. Every graph will turn to the right. Or, I should say, if it points down, it will actually turn to the left. Now, that's not so obvious looking at example 1 that your graph turned to the right, okay? It's actually a reflection, okay? It's a reflection not only over the not only just a simple reflection over the x or the y-axis, it's a reflection over the line y equals x. Now, this is where this gets kind of weird, but you know, if I were to draw the line y equals x, it would look like this. Okay? Here's the line y equals x. So if I come down this way, my line y equals x goes right over that. Now, hopefully in geometry you talked about reflections a little bit, but if you look at this, if you look at the vertex on my green graph, and you were to reflect that at a 90-degree angle over the line y equals x, you would get the vertex of the gray graph. That's what an inverse function is. It's a reflection over the line y equals x. Now, how do I know if the inverse is a function just by graphing f of x? Well, if f of x passes the horizontal line, or excuse me, if f of x passes the vertical line test, then f of x is a function. Okay, so that we know. We know about vertical line test. If the inverse graph, so again, I'm going to use some notation here. If f inverse, that's that little -1. It looks like an exponent, but it's not. If f inverse passes, well, actually, let me back up here. I want to change something. If f, we know that if f inverse passes the vertical line test, then it's a function also. Again, what we're trying to answer here is, how do I know just by graphing f of x? So if f of x, so if my green graph passes the horizontal line test, all right, horizontal line test. Slow down over here. Horizontal line test. And we're going to call that HLT. All right. Then f inverse of x will be a function. All right. Now, what do we mean by that? It means basically we know that my green graph is a function because it passes the vertical line test. If I can also get my green graph to pass a horizontal line test, so you run your pencil up the graph horizontally. Okay, so I'm just going to draw a line here. That's a horizontal line. That green graph touches that horizontal line twice, which means it fails the horizontal line test. Well, guess what? If my original function fails the horizontal line test, then my inverse function will fail the vertical line test. Okay? All right, so let's take a look at another one and see. It says graph the function. We have a parabola this time, and it gives us a restriction here. Oh, so we have a restriction that x is greater than or equal to 1. Interesting. So here we go. I'm supposed to graph this. That means I have a vertex at 1, -4. So I'm going to start right there. Go over to 1, down to -4. Right? So I have a vertex there. And my restriction says that I'm only supposed to be greater than or equal to 1. Well, my vertex is already at 1. So I don't need to graph the left side of this parabola. I just need to graph the right side. So greater than or equal to 1. So that would be up 1 over 1. Up 3, 1, 2, 3 over 1. And I could actually draw this parabola with that restriction. It would look just like that. Okay? So this is h of x. This is h of x. Okay? Now, h of x passes the vertical line test, because if you run your vertical line over that, it only touches it, ever touches it at one point. So it says in part A, will h inverse be a function? So in other words, when you see will h inverse be a function, what they're really asking here is, does h of x pass the horizontal line test? Okay, that's really what we're asking here. So the answer here is yes. Okay, and I've already given you the reason. Okay, yes, because h of x passes the horizontal line test. Therefore, I know that my inverse function, or my inverse graph, will be a function. Okay, now we're going to prove it in part B because it says to actually graph the inverse. So actually, let's do this. So to graph the inverse, I need some points off my graph here. So I'm going to list those three key points. My vertex was at 1, -4. I also had the point 2, -3, and I had the point 3, 0. So to graph the inverse, I'm going to go ahead and switch those around. So I should be graphing -4, +1. I should be graphing -3, 2, and 0, 3. Let's graph those. Now remember, this was the vertex, okay, of the original. 1, -4 was the vertex, which means that of the inverse, -4, 1 should be the vertex. All right, so here we go. -4, +1 is back here. -3, 2 is up here. And 0, 3 is up here. Now remember, this is the vertex back here at -4, 1. So the graph is going to roll up and around that way. And you can see that the blue graph will now pass the vertical line test. Okay? But now it actually wants us to write the equation for the inverse. Well, let's see how we do that. Number one, to write an inverse, you switch the x and the y's. So right away I'm going to switch and I'm going to write x equals y -1 squared -4. All right? So here we go. Let's think about how we're going to do this. I need to get y back by itself. So let's go ahead and add 4 to both sides. Plus 4. We have x plus 4 equals y -1 squared. To get rid of the squared, we need to square root both sides. Okay, so that's going to be my next piece here. I'm going to square root both sides. And I'm going to do that right here and right here. And remember, when we square root a function on both sides, we need a plus and a minus. All right? We need a plus and a minus. So now what I have is I have the positive and negative root of x plus 4 equals y -1. And if I add 1 to both sides, I get the positive and negative root of x plus 1, or excuse me, x plus 4 plus 1 equal to y. Now I want to get you in the habit of writing the right notation, so the y is really h inverse. So the inverse equation, okay, the inverse is going to be h inverse of x equals, now for just a moment I'm going to skip the positive and negative, x plus 4 plus 1, because in a positive square root function, a positive square root function rolls up and to the right like this. A negative square root function would roll down and to the right like that. Okay, so we could say that this is y equals the square root of x, and this is y equals the negative square root of x, and they would actually both come over to the point 0, 0 at the origin there. Okay, so if you look at my blue graph right now, it looks more like the top graph up here, y equals the square root of x, which is positive, not like the graph down below, which is curving down and to the right. So when I go to write my inverse equation, I need to decide, is it the positive root or is it the negative root? Well, if your graph is curving up and to the right, it's the positive root. If your graph is curving down and to the right, it's the negative root. So my inverse function, I don't have to put a plus right there. Okay, if it was negative, I would have to put a negative, but I can basically leave that out. Okay? So that is the inverse equation that would fit that blue graph, and it does pass the vertical line test. Okay? All right. So we're talking about inverse and one-to-one here. So it says a relation, which is basically a set of ordered pairs. We talked about this way back at the beginning in Unit 1. A relation is a function if for every x there is only one y. Okay? So for every x I only get one y on the graph. Okay? A graph like this would do that. For every x on that graph, there is only one y. Okay, and I'll just draw the parent function parabola. Okay, if I were to draw that graph as its inverse, it would look like this. And now you can obviously see that it doesn't pass the horizontal line test, or excuse me, the vertical line test. And you can also see, let's just call this x equals 1. I have a point here at 1 comma, which would be 1 comma 1, and I would have another point down here at 1 comma negative 1. So that does not hold true. If a function for every x there is only one y. The vertical line test will verify if a relation is a function. A function has an inverse if for every y there is only one x. Okay? So for every y there is simply one x. Again, if you look at my blue graph on the right side over here, if for every y there is only one x. Okay? So again, if you look at this, if this was our parent function done as an inverse, this point up here would be 1 comma 1. This point over here would be 1 comma negative 1. And there are two different y's with the same x. And so that is not a function. The horizontal line test will verify if a function has an inverse. So I run my pencil or whatever it is over the graph horizontally of f of x, and if it fails, then the inverse will not be a function. If a function has an inverse, then the function is one-to-one. Now what one-to-one means is that for every x there's one y, and for every y there's one x. Okay? So let's take a look at this next one and see how this works. It says find the inverse of this function right here. So we know that this is a function. This is a parabola. But it's restricted this parabola to where x is less than or equal to 4. Okay? So why did they do that? Why did they restrict it? All right? We'll talk about that in a minute here. To find the inverse of this, let's switch the x and the y. So I'm going to start off with x equals y squared minus 8y plus 6. All right? And I need to get y back by itself. Now there's only one way to do this, unfortunately, and that is completing the square. In order to complete the square, I need to isolate the y's. So I'm going to move this 6 over here to the other side, minus 6. So I have x minus 6 equals y squared minus 8y. Now if you remember, when we complete the square, what we do in order to do this is we take out the middle term of the squared part. Okay, so this is y squared minus 8y. We're going to take out the middle term. That's negative 8. We're going to divide it by 2, and we're going to square that entire result. So negative 8 divided by 2 is negative 4. Negative 4 squared is 16. I'm going to add that 16 that I get to both sides of my equation. So I'm going to add 16 to the left side, and I'm going to add 16 to the right side. Let's see what we have. So I have negative 6 plus 16, so that's going to give me x plus 10 equals, on the right side, I have y squared minus 8y plus 16. Now, why did we do that? Because what I just did was I created a nice, easily factored trinomial on the right side. I can factor the right side of this really easy. The left side is going to stay as x plus 10. The right side is going to factor into y minus 4 times y minus 4, which is actually can be written as y minus 4 squared. Okay? Now, how do I get the y by itself? I'm going to square root both sides. So my next step here is to square root the left and the right. I still need a plus and a minus over here. Okay? And then I'm going to have positive and negative square root of x plus 10 equals, and the square root cancels out the square, y minus 4. If I add 4 to both sides, I get y all by itself. I have positive and negative square root of x plus 10 plus 4 equals y. And now what I need to decide is which half of that do I need? Which half of that equation? Do I want the positive side or do I want the negative side? So I know that my inverse is going to be f inverse of x. And I know it's going to be one of the roots. It's either going to be root x plus 10 plus 4, or it's going to be negative root x plus 10 plus 4. Now, how do I decide that? I go back to my equation right here at the top, and I look at where x is less than 4. X less than 4 implies that this original graph, okay, so I don't know where the vertex is at on this original graph, but I know it's at positive 4. 1, 2, 3, 4. All right? If we were to actually find it here, we'd have, if I plug in 4, I get 16 minus 32 is negative 16 plus 6. So it'd be down here, way down here at like negative 10. It's pretty far down there. So this parabola, if I restricted it less than 4, it would be doing something like this. It's moving up and to the left. Okay? So I'm restricting the left side or the negative side of the parabola, which means I need the negative square root to be the inverse. Okay? So just to give you some heads up here, okay? If I graph a parabola, all right, and if I were to graph this side over here, right, this is what we would call the negative side, right? And if I were to finish that parabola, the right side is what we call the positive side. So when I go to do the inverse, if I have the negative side of the parabola, I want the negative square root. If I have the positive side of the parabola, I want the positive square root. Okay? So, it says to graph f of x and f inverse of x. Well, to graph f of x, okay, I'm actually going to graph f inverse first because I think it's easier. I've got a square root function. So I'm actually going to graph f inverse first. I think that's going to be the easiest way to go here. So f inverse has a starting point at negative 10, comma 4, all right? So in order to graph that, I'm going to have to change my scale here. So I'm going to have to do my grid here. I'm going to have to do my grid by 2's, all right? So I'm going to change the scale and I'm going to go grid by 2's. So I need to graph negative 10, 4. So that's going to be 2, 4, 6, 8, 10. And positive 4, 2, 4. So I'm going to be right here, negative 10, positive 4. Instead of going up 1 and right 1, I'm going to go down 1 and right 1, which is going to be down 1, right 1, so I'm going to be right there. Now I need to go down 1, right 1, 2, 3, which is going to put me right there. So this is f inverse of x. All right? F inverse of x. And then it says to graph f of x. Well, guess what? Since I already have f inverse, f of x should be easy. For f of x, I just need to switch the points. So I was starting at negative 10, 4. So f inverse of x should have the point 4, comma, negative 10. That's the first one. So that's going to be 2, 4, 2, 4, 6, 8, 10, right down here. Now, here's the nice thing. If I know my point pattern, I don't have to do anything else. I just need to determine, do I need the left or the right side? Because my square root was negative, I need the left side of the parabola. left side of parabola. Well, I know the point pattern for a parabola. It's up 1 over 1, and then it's up 1, 2, 3 over 1. And this would be f of x. I didn't even need to really do much math to plot those. Okay? You just have to know how to do a square root function. Is f of x 1 to 1? What that means is for every y is there one x, and for every x is there one y? The answer is yes, for just that reason. For every x, there is one y, and for every y, there is one x. That's what it means to be 1 to 1. Okay? So, example number 4 is asking the same type of question, but I want to make sure that I can restrict the graph to be 1 to 1. Now, what 1 to 1 basically means, 1 to 1 means it has to pass vertical line test and horizontal line test. Okay? So for f of x to be 1 to 1, it has to pass vertical and horizontal. Again, as we saw earlier, if you graph a parabola and its inverse, the inverse doesn't pass the vertical line test, the original doesn't pass the horizontal line test. Okay, so we can't do that. This one does not work. That doesn't pass both. So what I need to do is I need to figure out how to make that happen here. Now, if you think about it, if I were to graph this one, it has a vertex at -6, -4. Okay? So -6, -4 is going to be down over here somewhere. Okay? I'm not even going to bother to mark it. The -3 tells me that I'm going to go down instead of up. And so if I were to graph this, okay, it would look something like this. The entire parabola would look something like that. But I need to restrict this graph, okay, so that it's 1 to 1. So I can only use half of the parabola. So remember, I'm over here at x equals -6. I'm down here at y equals -4. And I only want to use half of the parabola. Okay? So what I could do is I could simply erase this half right here. And I could say, let x be greater than or equal to -6. And that way, when I go to graph the inverse function, I know that it will also pass the vertical line test. Okay? The other thing I could do is if I said, well, what if I wanted to do the other half? So what if I put that half on there? So I could say, or let x be less than or equal to -6. So then I would get the green half of the parabola. And what happens here is I'm left with half of a parabola, which is 1 to 1. Okay? Oh, looks like we got some more here. All right? I think, let me see here. Let's take a look here. Now we'll just finish up this lesson. I thought we were done here. All right? So, the next example says, find the inverse, and this is a square root function. So again, I kind of just want a picture in my head before I get going here. So I'm actually going to do a little sketch of this function. This function would look like this. It would have a vertex at 5, 1. So this would be 5, 1. So I'd have a starting point there. It's going to roll up and to the right just like that. Okay? So I know that my inverse is going to be a parabola. Okay? Because the inverse of a square root is a parabola. And since I have the positive root here, that implies that the inverse is the right side of the parabola. All right, so first of all, I need to find the inverse equation. So we're going to start off by switching the x and the y. So we have x equals the square root of y minus 5 plus 1. I'm going to subtract 1 on both sides because, again, our goal is to get that y by itself. So I have x minus 1 equals the square root of y minus 5. In order to get rid of a square root, we need to square both sides. So I need to square the left, I need to square the right, and so I end up with x minus 1 squared equals y minus 5. And if I add 5 to both sides, plus 5, I end up with x minus 1 squared plus 5 equals y. And now I just need to figure out how to restrict this so that I can call this h inverse of x. So I know that h inverse of x is going to be that parabola. It's going to be x minus 1 squared plus 5. But I need a restriction. X is going to be what? Is it going to be the greater than, or is it going to be the less than side? So if you take a look at this parabola here, it has a vertex at 1, 5. So if I were to graph that, here's 1, here's 5. Since my square root function is the top half, then that means I need the right half of the parabola. So I'd have a parabola that is greater than or equal to positive 1. All right? Pretty interesting, isn't it? Kind of cool the way all that works. Number 6, find the inverse of p of x. Well, p of x is just, again, finding the inverse means switch the x and the y. So let's do that. Let's switch the x and the y. All right? So I'm going to start off with x equals 2y over y plus 1. All right? I need to get the y's by themselves here. So this is going to get a little bit tricky or interesting here. In order to get the y, first of all, I got to get this y plus 1 out of the denominator. The only way I'm going to be able to do that is if I multiply both sides of this equation by y plus 1. All right, so if I do this, y plus 1 over 1. I'm going to do that on both sides here. So I would have x on the left side of it, x times y plus 1 equals, the y plus 1s on the right are going to cancel out, so that's going to be 2y. All right? And again, my whole goal here is to get the y's on the same side and eventually get them together as a single y value. So my ultimate goal is a y equals function. All right? So I'm going to try by getting rid of the x on both sides. So I'm trying to come up with a way to get the y plus 1 and the 2y together at this point. Okay? So let's see what we can do here. If I divide both sides by x here, I'm going to have y plus 1 equals 2y over x. All right? Now, how am I going to move the y next to the 2 over to the other side? I'm going to have to divide it out. Now I can either divide both sides by y, or I can multiply both sides by 1 over y. I'm going to choose to multiply by 1 over y. All right? So if I multiply the left side, y times 1 over y, the y's are going to cancel, and that's going to leave me 1. If I multiply 1 times 1 over y, it leaves me 1 over y. If I multiply the right side of the equation, the y's cancel, and I'm left with 2 over x. Now, I'm sitting here looking at this and I'm thinking, okay, well, I can't solve for y in the denominator, so this is still not done yet, okay? So maybe I can get a step closer by subtracting 1 on both sides. So now I have 1 over y equals 2 over x minus 1. And I'm still not there because, again, the y in the denominator right here, that's a no-no. I need it in the numerator. The only way I'm going to be able to do that now is to do one of two things. I can multiply both sides by y. I can do some common denominator work here. there's a few different ways that you could get this done, but I think that the easiest way is going to be to simply, let me see, how do I want to do this? So I was looking at my notes versus where I was headed here, and I was thinking maybe I could go a different direction here, but what I'm going to do is I'm going to take the right-hand side of this function, and I'm going to get the whole right side as a single fraction. Okay, so basically what I want to do is I want to be able to subtract 2 over x minus 1. The only way I can do that is with some common denominators. So I'm going to leave my left side alone for now. On the right side, I'm going to multiply my 1 over 1 by x over x. All right, so that's going to give me 2 over x, or actually once I have the common denominator, I can write 2 minus x over x. So again, if I multiply 1 over 1 by x over x, that just changes it to x over x. And then I can subtract 2 minus x, the common denominator is x. And the reason I did that now is so that I can go ahead and get this y value up on the right side. The only way I'm going to be able to get this y into the numerator is by multiplying it to the other side. The reason I did a single fraction on the right is so that I could do some cross multiplying. So at this point, I'm going to cross multiply. X times 1 is x. And y times 2 minus x is y times 2 minus x. Why did you not multiply that out? Why did I not distribute that? Because now I can take and divide out the 2 minus x on both sides. 2 minus x. These guys are going to cancel over here. I now have the y by itself, which means I know that p inverse of x is equal to x over 2 minus x. Whew. Boy, that was a handful there, wasn't it? Okay, so I'm going to leave it there for now. I know that there's one more example about verifying compositions, but we're going to leave it there for today, all right? Have fun.
Alrighty then.